In this video, we're going to go over some questions relevant to Newton's second law. And if you did the last set of questions for Newton's first law, that was a bunch of concept questions, so this time you get to get your hands dirty with a little bit of math. If I give you four forces, and all the quantities are Newtons, and I, J, and K represent the X, Y, and Z directions. So given these four forces, and given an object that weighs 10 kilograms, what's the acceleration of the object going to be? And you can give me the acceleration as a vector in the I hat, J hat, and K hat directions. You don't have to calculate angle, but if you're feeling adventurous, you can feel free to go ahead. So pause the video, do the solutions, and then we'll go over it together. So we have to start by consolidating F1, F2, F3, and F4 into a single net force. So force net equals what? Well, we sum up each distinct column. First all the I hat vectors, then all the J hat, etc. So adding these together, 30 plus 15 is 40, 5 plus 10 is 55, minus 40 is 15 I hat. 20 minus 30 is negative 10, plus 10 is 0, minus 10 is negative 10, minus 10 J hat, and then negative 10 plus 5, that's negative 5, plus 10 is positive 5, plus 20 is 25, so plus 25 K hat. And we said all of these forces are in newtons. And what we said is we said force equals mass times acceleration. So let's divide the force by the mass to get the acceleration. And it's important to remember force is a vector quantity, so is acceleration. So when we divide this through by acceleration, by mass, which is a scalar, we're going to end up with 15 over 10, so to get 1.5 I minus 1J, same deal, 1 over 10, plus 2.5 K hat. So this is all our acceleration vector, and since 1 Newton is a kilogram meter per second squared, we know this is in meters per second squared, which makes sense because it's an acceleration vector. So this is a combination of some skills you needed to know. You need to know F equals ma. That's the entire summation of Newton's second law, and it's very important. You also need to know how to add vectors together, and you need to know how to solve for acceleration. So because you knew how to do all those things, even though I gave you four complicated vectors, you're able to very precisely tell me exactly what the acceleration of this object is going to be. So good job, and now you're ready for questions about Newton's third law.